Today we're going to be talking about expanding and condensing logarithms. Since logarithms and exponential forms are related, they are going to have similar rules. In the exponential world, anything to the 0 power is equal to 1, and I like to use b for base instead of the a, so I'm going to change that here. Anything to the 0 power is equal to 1, and when you raise anything to the first power, you get that item back. So in log form, our rule is log base b of the answer 1 is equal to 0. And log base b of b is equal to 1. So I've just rewritten them using our general form. Log base b of the answer is equal to the exponent. So this is another rule that you can memorize, or you can always rewrite as an exponent and then evaluate. Log base 8 of 1. We want to know what exponent is going to make that work. So 8 to what power gives us the answer 1. Anything to the 0 power is 1, so our exponent would be 0. Log base 6 of 6 is equal to what exponent? So 6 to what power is going to give me 6? My exponent would have to be 1. Log base 13 of 1 means I'd have 13 to what exponent equals 1, and anything to the 0 power would equal 1. Log base 9 of 9 will be 1. Log base 5 of 0 will be, log base 5 of 1 will be 0, and log base 7 of 7 will be 1. Remember, we have 9 to what power is equal to 9, so my exponent would have to be 1. 5 to what power equals 1, so my exponent will have to be 0. And 7 to what power equals 7, my exponent would have to be 1. For our next property, we have base b raised to the log base b of x power is equal to x. Now, proving these two properties is a little bit more in-depth than what you really want to get into at this point. So the main thing to remember is that when you have a base and its exponent is log with the same base, they're going to basically cancel out and we end up with the exponent as our answer. It doesn't matter if the base is the main part of the problem or not. Log base b of b raised to the x power is going to equal x. I'm going to end up canceling out my log base b and b, so x is what's left over. So evaluating these, 4 raised to the log base 4 of 9. 4 and log base 4 are going to cancel out, give me 9. Log base 3 of 3 raised to the 5th power. Log base 3 and the base 3 are going to cancel out, leaving me with a 5. 5 raised to the log base 5 of 15. 5 and log base 5 will cancel each other out, leaving me with 15. Log base 7 of 7 to the 4th power. Log base 7 of 7 will cancel, leaving me 4. 2 raised to the log base 2 of 8 power. 2 and log base 2 will cancel, leaving me with 8. Log base 2 of 2 raised to the 15th power. My log base 2 of 2 will cancel out, leaving me with just 15. Next, we're going to look at the properties rule, the product property rule. And in the exponential world, if we are multiplying like bases, we get to add the exponents. In the logarithmic world, we're going to have a similar rule. When we have our multiplying log with the same base, we can expand that by taking log base of m plus log base b of n. So we have addition in our exponent rule, and we have addition in our logarithmic rule. Yep. Throw that out. All right. Now, I'm going to use my expansion property. Log base 3 of 7x means I'm taking 7 times x. So I want to expand this. Log base 3 of 7 plus log base 3 of x. There is nothing that I can take 3 to a power of to get 7 for an answer. It is a whole number, so I will leave it as log base 3 of 7 plus log base 3 of x. Log base 4 of 64xy will expand to log base 4 of 64 plus log base 4 of x plus log base 4 of y. 4 to what power will give me 64? That would be 3. So log base 4 of 64 changes to a 3. And I keep log base 4 of x plus log base 4 of y. Log base 3 of 3x expands to log base 3 of 3 plus log base 3 of x. 3 to what power will give me 3? The answer is 1. So I have 1 plus log base 3 of x. Same types of problems, expanding. Log base 2 of 8xy will become log base 2 of 8 plus log base 2 of x plus log base 2 of y. 2 to what power gives me 8? 2 to the third power would give me 8. So log base 2 of 8 changes to a 3 plus log base 2 of x plus log base 2 of y. Log base 9 of 9 plus log base 9 of x. 9 to what power would give me 9? That would be 1. So this changes to 1 plus log base 9 of x. The last one, log base 3 of 27 plus log base 3 of x plus log base 3 of y. 3 to what power gives me 27? The answer is 3. So I now have the answer 3 plus log base 3 of x plus log base 3 of y. The quotient rule in the exponential world says when we divide like bases, we get to subtract the exponents. And in the log world, when we are dividing using the same log, we can expand this by subtracting log base b of m minus log base b of n. So using that property, log base 5 of 5 over 7 becomes log base 5 of 5 minus log base 5 of 7. 5 to what power equals 5? The answer would be 1. And 5 to what power equals 7? Can't do that easily, so I leave it as log base 5 of 7. Remember that if you don't have a base written, it's understood to be base 10. So I have log base 10 of x minus log base 10 of 100. 10 to what power would give me 100? The answer is 2. So I will rewrite this as log of x minus 2. The base 10 is not needed in the problem or in the answer. However, I wanted to show you the relationship between my log base 10, 100, and the 2. Log base 4 of 3 minus log base 4 of 4. 4 to what power gives me 3? There isn't anything friendly, so I leave it as log base 4 of 3. 4 to what power equals 4? My answer is 1. So I have log base 4 of 3 minus 1. Remember, when I don't have a base written in, it's understood to be a 10. Log base 10 of x minus log base 10 of 1,000. 10 to what power gives me 1,000? That would be 3. So I end up with log of x minus 3. Log base 2 of 5 minus log base 2 of 4. There is no whole number. I can take 2 to a power of and get the answer 5. But I can use 2 to the second power to get 4. So my answer will be log base 2 of 5 minus 2. Log base 10 of 10 minus log base 10 of y. 10 to the first power would be 10. So I have 1 minus log of y. Next, we have the power property rule. In the exponent form, when we raise a power to a power, we multiply the two exponents. In logarithmic form, when we have a log raised to a power, we also multiply. We're going to basically bring our exponent down in front and multiply it by our log. Log base 5 of 4 to the third becomes 3 times log base 5 of 4. I can't raise 5 to a nice power to get the answer 4, so I leave my answer the way it is. I'll bring my 10 down, get 10 times log of x. Bringing my 4 down, I'll have 4 times log base 7 of 5. 7 to a power equals 5 is not a friendly number to find, so I leave it as 4 times log base 7 of 5. $100 log of x. 7 times log base 2 of 3, and 20 log x. There is no number I can take 2 to the power of to get 3 friendly, so I did not simplify that. Now we're going to put some of the properties together. Log base 4 of 2x cubed times y squared. The first thing that I'm going to do is check to see if there is a radical in the problem. If there's a radical, I'm going to change it to a fractional exponent. Remember that square root of x is x to the 1/2 power. Cube root of x is x to the 1/3 power. Fourth root of x is x to the 1/4 power. Fifth root of x would be x to the 1/5 power, and so on. If we've simplified it to a fractional exponent, then our next step is to look to see if there is an outside power. An outside power would be a number that's on the outside of my parenthesis. I don't have one in either of these examples. Next, I'm going to expand by using plus or minus. Then I will use my power rule. And finally, I'll look to see if I can simplify any values. So there is no radical, there is no outside power. So next step is to expand. Log base 4 of 2 plus log base 4 of x to the 3rd plus log base 4 of y squared. Power rule, any exponents that I have are going to get to come down to the front. So now I have log base 4 of 2 plus 3 log base 4 of x plus 2 log base 4 of y. 4 to what power is equal to 2? Well, the square root of 4 is equal to 2. That would be 4 to the 1/2 power. So my exponent here would be 1/2. So now I have 1/2 plus 3 log base 4 of x plus 2 log base 4 of y. Log base 2 of 5x to the 4th y squared. No radical to change, no outside power, so I start off with expanding. Log base 2 of 5 plus log base 2 of x to the 4th plus log base 2 of y squared. My powers are going to come down to the front. Log base 2 of 5 plus 4 log base 2 of x plus 2 log base 2 of y. I can't simplify log base 2 of 5, so this is my answer. Next, no radical, no outside power, so now I am going to expand log base 3 of 7 plus log base 3 of x to the 5th plus log base 3 of y to the 3rd. Bring down my exponent, get log base 3 of 7 plus 5 log base 3 of 6 plus 3 log base 3 of y. I can't simplify log base 3 of 7, so this is my answer. Next one, I do have a radical to change, so I'm going to change this to log base 2 of x to the 3rd over 3y squared z raised to the 1/4 power. Then I'm going to bring my 1/4 power to the front because that's my outside power. So I have 1/4 log base 2 of x to the 3rd over 3y squared z. Now I can expand. When I expand, I have to expand the 1/4 with my log base 2. So I have 1/4 log base 2 of x to the third plus 1/4 log base 2 of 3. Sorry, that won't be a plus, that will be a minus because it's on the bottom. Minus 1/4 log base 2 of y squared minus 1/4 log base 2 of z. Now I can use my power rule and take my exponents down front. 1/4 times 3 is going to give me 3/4. So I have 3/4 log base 2 of x minus 1/4 log base 2 of 3. 1/4 times 2 is going to be 2/4 or 1/2. So I have minus 1/2 log base 2 of y minus 1/4 log base 2 of z. I do not have a way to simplify log base 2 of 3, so this is my answer. Fifth root, I'll have log base 4 of x to the fourth over 2y cubed z squared raised to the 1/5 power. My 1/5 power will come down front. I'll have 1/5 log base 4 of x to the fourth minus 1/5 log base 4 of 2 minus 1/5 log base 4 of y to the third minus 1/5 log base 4 of z squared. Exponents come down to the front. That'll give me 4/5 log base 4 of x minus 2/5 log base 4 of 2. Sorry, that's an exponent, that's a base. So that stays as 1/5 log base 4 of the number 2 minus 3/5 log base 4 of y minus 2/5 log base 4 of z. Now I do have a way of taking 4 to a power and getting 2. The square root of 4 is 2, so that means it would be 4 to the 1/2 power. So my negative 1/5 is now going to be multiplied by 1/2. Everything else remained the same. And then whenever I multiply this, I get 1/10. So my final answer will be 4/5 log base 4 of x minus 1/10 minus 3/5 log base 4 of y minus 2/5 log base 4 of z. Next radical problem, log base 3 of x squared over 5yz to the 1/3 power. I'll have 1/3 log base 3 of x squared over 5yz. That'll give me 1/3 log base 3 of x squared minus 1/3 log base 3 of 5 minus 1/3 log base 3 of y minus 1/3 log base 3 of z. Bring down my 2 to give me 2/3 log base 3 of x minus 1/3 log base 3 of 5 minus 1/3 log base 3 of y minus 1/3 log base 3 of z. I cannot simplify log base 3 of 5, so this is my answer. Now we're going to go in the opposite direction and we are going to condense. In condensing, anything with a plus means that it came from the top, and anything with a minus in front of it means that it came from the bottom. So I want to condense this into one log, base 4, and this will be of 3 times x divided by y. Next one, I have a little typo here. That should also be a log base 2. So I condense log base 2 of 5x over y. And the next one, I have log base 3 of 6 over x, y. Both the x and the y come from the bottom this time. If there's a number in front of the log, that means that it came from being an exponent. So we're going to put it back in its proper place. So here I have log base 3 of x to the second power plus log base 3 of x plus 1 to the fourth power. Addition means that it came from multiplication. So I'll have log base 3 of x squared times x plus 1 to the fourth power. Next problem, 2 log x plus 2 log x plus 1 will be rewritten as log of x squared plus log of x plus 1 squared. Condensing this will bring it back to multiplication. So I've got log of x squared times x plus 1 squared. One other thing to watch out for is if we have a fraction. So let's change this to 1/2 instead of 2. This would change the problem to log x raised to the 1/2 power plus log of x plus 1 to the 1/2 power. Condensing, I would have log of x to the 1/2 times x plus 1 to the 1/2. I would rewrite it as a radical, and because they're the same radical, they can go under the same radical symbol. They're both square or 1/2 power or square root. If one was 1/2 and one was 1/3, then I would have to keep them separate. You may also see these types of problems written as log x divided by 2 plus log of x plus 1 divided by 2. That just means that you have 1/2 times log of x and 1/2 times log of x plus 1, and then your 1/2 would go up to the top. So when you got a log divided by 3, it means that it's 1/3 times log of x, which is going to change into log of x to the 1/3 power. The last type of problem that I want to show you real quick when you're condensing is what happens if you have a whole number involved. Well, if you have a whole number in there, you have to figure out what it came from. So this would be log base 2 of x minus log base 2 of something, and I don't know what that number is. So it's telling me I've taken 2 to the 3rd power to get what answer? That would be the number 8. So this would be log base 2 of 8. Now that they're both the same log, I can condense it to get log base 2 of x over 8.